Hello everyone, my name is Walid and welcome to session 3 of the printed circuit board design principles and practices. In our today's session we will have the following outline. We will start with creating an Altium Live account and downloading Altium Designer. Then we will go over the Altium Live products, community resources that are all available on Altium website, and these are important stuff to start with. Then we will run Altium Designer and we will take a look at Altium Designer environment. We'll review the menus, panels, and all the functions or generic functions in Altium Designer. Then we will discuss Altium Designer various documents and extensions, and we will end this session with also a quick look on Altium Designer project types as well. So let's get started with reviewing or taking a look at Altium Live website. There are a lot of neat stuff over there. We need to make use of these, and I need to make sure that you are aware of all these like treasures available on the website. So let's go to live.altium.com. So the first thing you need to start with is to create an account, and to do that you need to sign in here, and you suppose you don't have an account, so you click on join Altium Live, and here you need to fill your information, acknowledge that, and submit, and then you will have an account you can use. Once you have an account, you can use this account to log in. So once you log in, you have this menu in here. The first thing you need to do is to download Altium. Don't click on the free trial. You need to go to product in here, or you can click on home. So once you click on home, you have products, you have downloads in here, and then make sure to download the latest version of Altium Designer, which is, for now, it's 19.1.5. This is the latest. So you can have offline installer or online installer. During the installation, you will be asked to log in into your account as well. So you need to do that for sure. Now, if you don't have a license or you don't have a subscription to Altium Designer, you may request free trials. Usually the free trials around 15 days or 14 days, and you might be able to ask for an extension. If you are a student, you might be able to purchase Altium Designer student version, which is a full version after all, but you cannot use it for any commercial designs or commercial applications. You might get it for 200 or around $200 or even less that. And most of the university, they have university programs where you can have access to Altium Designer from the university server for free. So just check with your university or institution. If not, and you are a student, you can maybe purchase Altium Designer for $100 or $200. That's it. The next thing you may want to take a look at is the community. They have a huge community on Altium Designer, starting with the forum. So on the forum, you can search for questions and you can find a lot of answer around that. So if you search for integrated libraries, for instance, oops. So you will find a lot of questions about integrated libraries, and some people had a problem and how they fixed it. So also you can sort them into featured questions around the libraries, unanswered. If you have any questions, you can find them in here as well. So the forums are very effective, where you can share experience and knowledge with other users of Altium Designer. I highly recommend to take a look at the forum. Ideas, if you have any ideas in like adding a new feature to Altium Designer that make it more robust, go ahead and post your idea here by adding an idea, and they will vote on it and rank it. So here you can see the released ideas and the date of release based on the release version of Altium. Here you can see the ideas that are in development. They are working on this. Like for this idea, I like it. So they are gonna add the rule for PCB cutout to calculate the cribbage distance when you talk about high voltage design, and you need to make sure you have enough spacing between the traces at high voltage so you can calculate the cribbage distance. This is a nice feature if they are working on it. So this is good. So this is for the ideas. Here you can submit an idea. Blogs, this is a great place and I always go there. You can find a lot of nice article that you can learn new stuff from it. For instance, I was looking into this. So how to design the perfect PCB stack up with Altium Designer. This is very neat article. I was looking into it and reading through, and there is really some nice information in here. So sometimes I go and start reading here. Sometimes you find a video and or advertisement or something. This is very nice stuff in here. So I recommend to go into the blog and start reading or following some of the things. Beta program, I'm a part or a member of the beta program. So basically beta program, you will get the chance to test the latest beta release of Altium Designer, and if you find any issue with that, you can send it to the beta community and they will work on fixing that. So it's good to be there, but they require professional people only to work on that, and because you will get the chance to experience the latest features or new stuff coming in Altium Designer before anyone else. So this is for the community. Now the most important part on Altium Lab is the resources in here. Resources, the first thing is the documentation. So in the documentation, and Altium Designer help is very well documented. So you can go, let's say you need Altium Designer, you click on Altium Designer, and here it's tabbed in here, and you can select the version you are using with Altium Designer, and then you click on search. For instance, if you want to search for create a project, for instance, or anything, you can filter it out of course. So create a project, you click on it, and you can see it's Altium 19.0 basic. Oops. So you can screw up and you can switch to 19.1 if there are new features or new revisions to the help. You can see it, and here you will get information how you can access that, how you can do it step by step, and it's very nicely written help, so you can count on it. And I go there all the time for new information or learning new stuff whenever new release of Altium is out. So this is also very important part, the documentation. It's very well written. The second one is the design content. This is huge. This is really huge. So design content is or are classified into unified components. The unified component is basically you can find a component from different manufacturers, and if you want to access the list of the manufacturer, these are some of the manufacturers published Altium Designer libraries for their component. So you don't have to create the component, you can just come here and download the library. For instance, if you can search, for instance, let me see all the components from Atmel. So these are the components from Atmel for MCU wireless, RF identification, touch solution, microcontroller, Mega AVR, and so on. So many libraries from Atmel, and each one of them might contain like 100 and 1,000 of components. So you click on it, you will get details about it and what kind of chips in it, and here you can see the parts in it. It's 655 pages of parts, and each page has almost 50 parts. And if you click on the part, you can go to Altium Vault, which is the server or the repository for the libraries on Altium. And here you will see information about the chip, etc. Of course, and you can go back and download the library if you want to use this library. You can download it, and this will become an integrated library format. And here is the library. To install this library, just double click on it and it will be installed into Altium Designer. We will talk about that later. We are just now doing quick review. So this is for the unified component. What if I want to search for a specific component? Yes, you still can do that. Let's go back to the resources, design content, and here let's search for STM, for instance, 32F1. Let's see what we have for F1. Okay, so we have a family of F1 microcontroller, and you can basically click on this. You can download either the whole library in here, or you can search if you can find a specific microcontroller, let's say STM32F103. Oh, why is this? Okay, for some reason this is stuck in here. It's not moving. Yeah, so this is for the unified component. Nanoboard examples. Oh my. Okay, let's refresh. Okay, nanoboard examples. These are like examples you can run on boards from Altium Designer. These boards are called nanoboards. If you search for these boards, you can find them. Mostly they are FPGA based board where you can run some of these examples. Template design. This is also something is very important, and here you can find a template mostly for these. These are connectors or board or PCI Express boards. You don't have to make the shape of the PCB to be like similar to PCI Express. You can download the template from here. For instance, if you have ATX computer motherboard, there is a format for that. You can download this format and use it right away. So you have a template, it's ready off the shelf. You can just use it. You don't have to create that from scratch. You have a lot of templates in here. You can download and use whenever needed. And in order to find the template you want, you need to search for a specific thing to find it. For example, let's search for compact PCI Express system. Let's see what we can. Okay, so you have all these different templates depending on the system and the type of the system you are using. Basically, you click, let's take this template for instance. Here you can see the 3D format, and here you can see the 2D format of the PCB, and here you can see the schematic for this connector. Because you have a connector with so many pins, so even they will create the schematic for you. The schematic is created, you can use it right away. All that you need is to add this one to your design. So basically you download, go to Vault and download this and use it right away if you want. Or you can take a look at the PDF as well. So let's go to Vault and download that. It's okay to practice. Here you can see the save button on that. Save. So let's take a look. Extract. Okay. So we have the design in here. This is the design in Altium. Let's open Altium Designer file. Open project. Let's local browse, and we can go to the project file in here. So let's take a look. So this is the schematic. Of course, we'll discuss Altium Designer in details today in our session today, but this is a quick review how we can import and use the resources available on live.altium.com. So this is the schematic. As you can see, let's open the layout and explain what I'm talking about by template. Okay, let's close this information mesh. So this is the template in 2D. As we can see, if we can take a look at the configuration, and by default they have 4 layers in here, and here you can see the connector, and these are the outline for the PCB. These are standardized. There are specific standard for this compact PCI Express system _2. So if we click on view and we switch to the 3D layout mode in here, and we can rotate that, and here you can see the connector or the interface, and you see how many pins you have, 100 of pins. And this is the PCB. Now all that you need to do is to go back to the schematic, add your sheets in here, connect with these pins, generate your layout, port your component into here, start placing them in this PCB area in here, and connect them as well. You don't have to change the size of the PCB at all. This is what we mean by template, so off the shelf. So let's close this project. Now let's go back to Altium Designer. Here, these are the template reference design. These are also great resources to learn something new from Altium Designer. So for instance, let's download this example. This is one of the famous examples. Is a USB-G tag adapter for programming FPGA with the Nano board from Altium. So all that you need is to click on download zip, and here let's unzip this folder and go to Altium Designer. Again, file, open project. Make sure to click on open project, and in this case you only can see the project file because the folder will be full of other files as well. So you need to access the project from the project file. So starting with the schematic in here, we can see the schematic, and this is hierarchical design. Each one of these is subsystem, and also this is just quick view. We'll talk about that in details and how we can create hierarchical design like that. So if you click on this, you can access the schematic symbols for these chips on this sheet. Now let's go to the layout, which is this one, the PCB document. And in our session today, we'll talk about the various types of documents in Altium Designer. So let's start in the 3D mode. So let's switch first to the 2D mode. And here we can see the layout, the component, etc. So if you go to the configuration, we can see that we have 2-layer PCB, and here we can see the components overlay and the solder base, etc. If we switch to the 3D model, you can see there is something covering the board, which is an enclosure ported from MCAD software. And how you can do that is basically go to place, 3D body. You can add a 3D body into your design, or you can create 3D body using extruder and some simple components in Altium Designer itself. You can do that. So let's try to click on this 3D body. Okay, I think it's this guy. Properties. Let's try to. Okay, so this is the 3D body. It's important to a mechanical layer. Let's make it transparent a little bit so we can see what is underneath that. Okay, here. Okay, a little bit more. So we can see the PCB underneath it, and we have the 3D body. And the reason for that, now you import this mechanical design from the MCAD engineer, and you try to do a clearance check. Make sure that everything will fit together and there is no problem with the clearance. And for instance, let's try to move this a little bit. You see there is a collision in here, there is a collision in here, and you try to fit that and see if there is any collision. You send it back to the mechanical engineer and explain. Now let's remove this for a second. let's move it to the side, put it on the side, and here we can see the 3D model for our PCB. And this is like very nice 3D model. It's fits 100%. Here you can see you have a card, a memory card, and here we have two LEDs. We have a USB connector in here on this side, and we have the G-Tag connector on this side. And it looks very nice, very nicely done. And this is the 3D model. You can fit it into it and to try to do the clearance check. This is just one of the examples. It's already examples. And what I usually do, I look for complicated examples, download the examples, and see how they connected things, how they designed it, and put them together. Sometimes you find nice stuff to learn from. So I always go there and see what they are doing and what kind of reference design they have. For instance, I think they have nano board, one of the advanced nano board in here. Let me see if I can find it. So, and yeah, this one. So this is very advanced nano board and has a lot of chip and high speed buses and stuff like that. So I doubt, and this one is 10 layer, similar for this one as well. So you can see how they created the stack, how they designed everything and put them together. Here is the board. It's big board, it's a huge board, and here you can see the layout. Look how much it's complicated. Let's download this and take quickly look on it and take a look at the stack layer, how they designed the layer stack, and if they used any micro vias on this. So here, let's go to Altium Designer. Let's close this project. Save none. Open project. The following device sheets couldn't be found. That's you wish to add no device sheet folder. No, that's fine. So this is a schematic. Also hierarchical design. You see each one of these is a subsystem. You can click on it, hold control down, left click in the mouse. You can go to the sheet. This is an FPGA chip, and FPGA has so many pins. Sometimes they go up to 1024 pin on a single chip. It's a huge, I know. So let's take a look at the layout now. It takes some time to load up. And this design was created, by the way, by Altium Designer. So they created these reference examples, which is good, and they are the best to use the tools. And sometimes I learn tricks also from these designs. Okay, let's close this. Okay, let's see how many layers they have on this board. Or first, let's take a look at the 3D model of this board. So you can click on number 3 on the on your keyboard, or you can go to the view 3D and still loading. You see there is a model in here still loading that. So give it some time. If the board is huge and complicated, take some time to load the 3D model, especially the external ones. So this is the bottom side of the board. Look how real the board is. If you take a look at the fabricated board and assembled board, it will look almost the same. So sometimes it helps to switch back to the 2D model. Oh, here we go. We got it. So switch back to 2D and then 3D. It's the graphical card on your laptop or PC is a little bit slow. So this is connector, looks like the PCI connectors in here. And here we have another card, like FPGA card. So we can move this card on the side. So they fit this FPGA card into the motherboard. Looks like this is a motherboard in here, and they fit an FPGA card to the motherboard, and they do also clearance check. So this is a module by itself. They created this module in a separate board, And also this is another module, you can move it. They created that on also on separate board. And here are the peripheral boards connectors. You can connect them here right away. So imagine that you created this motherboard and then you created these modules. You went to the fabrication and you came back. This will cost a lot. This will cost a fortune to build, especially for prototyping. And you try to fit these connector on this board with this guy, and oh, you have 1 millimeter difference in the connector spacing, and there is no way you can plug this to the board in here. So you have two options. The first option is to redesign this board or redesign this board, and this is uh, you have time, cost, and you have also the cost of the board, and you have engineering cost. But now here you don't have to do that. All that you need is to come here and try to see if they fit together and start doing the assembly and transfer the top one into transparent and see how it fits with the bottom one, and we'll talk about this in details later on. Now what's interests me is to see how many layers they used on the motherboard. And I would, okay, we can cheat a little bit. What we can do, we can slide it like that. It looks like 8 layers. We can go to view configuration. Again, it's just a quick review on Altium Designer. We'll discuss all these in details. We can go here to the board thickness scale. We can scale the thickness, meaning we are spacing these layers and scaling them. So let's count 1, 2, 3, 4, 5, 6, 7, 8 as I expected. And here you can see the vias connecting all the layers. And it's clear that they only have a through-hole vias. I don't see any micro vias or buried vias or stacked vias or skip vias. So basically all of them are through-hole vias, and this makes sense. This makes sense because this is very cheap to be done. Once you go to buried via and micro vias, the cost will increase significantly, and you really don't want to do that unless you have to do it. And this is a big board, it's not a tiny board, and you are trying to minimize the size of the board to use micro vias. So now let's take a look at the stack layer for this board. So by the way, you can go inside here, you can go inside and start look into how these vias are connected, and it's very interesting how they make the 3D model in Altium Designer. So basically you can go to the design layer stack manager, and let's take a look how they design the stack. Okay, here we go. So we have 8 layers. They used core, pre-break core, pre-break core, and so we have 1, 2, 3, 1, 2, 3, 4. So the design in here, as you can see, they used 4 cores and pre-breaks, and you can do that, of course. You are not limited to have a pre-break and a core between the two pre-break. So basically, they put a pre-break between the cores, and that's also fine. Let me take a look at the maximum thickness of the board. It's here. Yeah, that's why it's 75 mil. This is the maximum thickness. It's not thick. It's not thick. So let's take a look at the VS type. So as we can see here, they only have through-hole via, nothing else at all. And here we can also visualize the layer stack as we saw that 3D full stack. This is the stack. They only have through-hole via. Okay. So this is just one of the examples. So if you go to the PCB now, here let's go back to the 2D model and let's take a look at the layers. So these are the 8 layers, cover layers. So let's hide all of them. Let's hide the component, let's hide the mechanical layers. So if we show the top layer, So this is the top copper layer. If we take a look at the bottom layer, which is the bottom side of the board, this is the bottom. This is the first inner layer. You can see traces. These are the traces. So if you click on the trace, you can see the size of the trace. So the width of this trace is 5 mil. It's interesting. Yeah, 5 mil is quite acceptable or standard size. So this is the third layer. Now they have plane, as you can see. We will talk about the planes. This one is ground, and this one is power. Basically, these planes, everything is filled with copper. There is no etching. It's like the copper foil without any etching on it. It stays as it is, and the vias connect from different parts into this plane layer. So here is the layer number 6, layer number 7, and they have so many traces. Now layer number 8, let me see if they have differential pairs. I don't see any links matching somewhere. They should have some. But this is in general. You can just take a look, try to practice, download this example, and try to see how they created the layers, the schematic, and also the layer stack. It's good to start with these examples. Now, the most interesting example to start with when you first install Altium is the sample example they have, which is the mini PC. This is multi-board project, and it's very interesting. So the motherboard, you can start with the motherboard. This is a huge example. You have a motherboard and you have a fan on the top for cooling down the CPU, and everything was done within Altium, and it's really amazing how they were able to improve the 3D engine within Altium Designer to work in that smooth performance and behavior as well. So let's take a look. This is 16 layer, as we can see in here. 16 layer board. This is a huge. So they are saying click of F5 for enable disable net color highlight. Also, we will talk about this one because you can specify net color for specific nets, and when you click on switch to the F5, you can see the color based on the net name or the functionality of the net. And these are the links matching we were talking about for differential pairs, and we need to have a long session to describe when we need to match the links of the traces and how we can do that in Altium Designer and other tools as well. So if we take a look at the 3D model for this board, I'm exploring all these boards and trying to run them and here because I need you to get the chance also to take a look at these boards and try to review them. So here we go, came up. So this is the motherboard. They have a fan, they have connectors in here, mini PCI Express in here, PCI Express connector in here, and Ethernet connector and different kind of connector on the board. So if we flip the board, you can see the bottom, what is on the bottom, and this is 16 layer PCB. Now let's take also a look at this and see if they used any micro via on the stack. So we go to the design, layer stack manager, and here you can see the FPGA chip. Let's go back, sorry. The FPGA chip, this chip from Altera. Of course, Altera was acquired by Intel, so now Intel on Altera. So this chip has so many bins count, as you can see in here, and everything is routing to the 16 layer. Now let's go back to the layer stack and see the via type. They also used only through hole via. This is very complicated board, and they did not use any micro or buried vias, only through wall via, and that was enough for them. And if you go to the 3D model again, and you want to take a look at the construction of these tires, you can basically go to the view option and start scaling these. Here we go. So basically, these brown pillars, these are mechanical holes. They don't have any cover. These are, you can see how this via connect with the layer in here. These are called thermal relief. We will talk about these thermal relief. And here you can see they are not connected. It's just passing in this. If you need to have a connection, you can connect, otherwise you can just pass. Okay, so let's go back to the live just to explore more materials. So this, we take a look at the design content. Now support is also important. I would report that. So you can post your question and create a case. Altium technical support team will come back to you and answer your question and try to help you. Or you can go to the self-service and you try to find an answer from Q&A forum where other problems were reported and the solution is posted. So you can check if you can find a solution for your problem or your question. Or if you have a subscription to Altium and you already have active subscription, all that you need is just to call this toll-free line, and one of the technical support team will get on the line with you. And Altium, they use Zoom. It's like a software, it's called Zoom, where you can share your desktop and give them a control, and they can see the problem happening on your machine and they will try to fix it for you. So they are very effective, especially in the company. I don't have time to spend on fixing some issues, or I need to solve it. I just call them right away. They will ask me, they will provide me a link where I can run Zoom on my machine, and they will see the problem happening on my end, and they will advise me how to fix it right away in real time without wasting any time on that. But you need to have an active subscription with them. Now, resources and webinars, it's very nice as well. There are a lot of webinars, important webinars. You can take a look. Some of them are, these are free. All of them are free. So these are coming. You can also filter in English, for instance. These are coming, and these are watch on demand. So anytime you can watch these. If you have any interest, for instance, understanding rules and constraints, this is very nice one. I watched this one. Multi-board design basics in Altium Designer. Also, this is nice. This is basically what we are talking about in here, this board. And you can see these, they are very nice and very helpful. Technical papers, same thing, and you can find a lot of nice information in here. These are technical papers written by Altium, and they have very strong information, getting the layer stack right first time. This is a nice article I read a long time ago. BGA fan out, how to fan out the BGA and routing, stuff like that. So these are very helpful. In order to master PCB design or to master a tool, you need really to spend time on reading, practicing, see how things can be done, learn the best practices, and so on. It's not something easy you can learn overnight. This is comes with experience. You need long time to read and practice to be master in the tool. So this is enough for Altium Life, and we can go back now to our slides. So we created an account, we took a look at Altium Live products, community resources, etc. Now, Altium Designer environment, we can now take a look at Altium Designer environment and see all the menus and the panels, and it's just a quick look. We'll describe and see how we can use each one of these panels and what are the functionality of each panels in details. Everyone in time, so we don't want to spend time just explaining these panels and the functionality. We will explain the function when you need to use it, and in this case, you will not forget the location of the function, how you can access it, and how you can use it. So, yeah, we saw this Altium Live. The environment. Okay, let's run Altium and start. Take a look at the environment piece by piece. And this is basically the example I ran from Altium. And when you install Altium, you will find this example in the examples folder. And Altium provided these examples and make it available for the users, so you can learn a lot of it because it's 16-layer PCB and there are a lot of information in this design. Altium Designer is a unified design environment that implies all the tools needed to create an electronics product or PCB within a single application. For instance, it includes a schematic capture, layout, circuit simulation, signal integrity analysis, power integrity analysis, and other tools as well, such as ECAD, MCAD integration. On the top of that, Altium Designer environment can be customized to meet a wide variety of user requirements and specifications as well. So before we can access the benefit of Altium Designer, it's very important that we familiarize ourselves with the environment, the features in this environment, and the common GUI elements we can use. When you first start Altium Designer from the Start menu, the first thing you will see is the main workspace. So this workspace will include menus in here, active bars, and panels, and in addition to editors that can be quickly accessed and quickly changed. Now, while the contents of the menu, active bars, panels, and the editor itself can change according to what document is loaded and which one has the focus, the interaction between the user and the environment will be consistent. So let's start by loading one of the project to talk about the editor view. So we can open a project on local drive, for instance, and let's have the project itself. Let's open one schematic sheet. Now we will talk about the project types and document types later on, but we need to start taking or take a look into the environment first. Let's open also assembly or layout document as well. So it will open in a second. Okay, assembly layout. And this is basically the design we'll work on during this class. Okay, so let's hide this. So the editor view is used to display the design data ready for editing. This is the editor, and the different document editor will be loaded depending on which type of document has the focus. For now, the layout document has the focus. If we switch to the schematic document, now you have the editor in here. As you can see, this is the editor for the schematic documents, and this is the editor for the layout document. And each editor contains its own set of commands and actions that are appropriate for the document being edited. So there are a specific set of commands and panels for the layout editor, and there is also a specific set of command and panels for the schematic editor, and so on. Now, each document is associated with a tab in the area referred to as document bar. This is a document bar. Every time you open a new document, it will go into the document bar in here. So you can open as many as you want. And once the document bar is full, they will start combined into groups in here. Now, if you press on the keyboard Ctrl and Tab, you can cycle through these different tabs. So the shortcut for that is Ctrl and Tab. Now to control how these tabs are arranged, basically you can do that from the window menu, or you can right click on any one of these tabs or on the tab itself here, or you can drag, left click on the mouse and drop this. Now let's assume that we want these to, let's close this one and this one. Let's say we need half of the screen to be for schematic and the other half for the layout. We can split vertically, and now you have the schematic on this sheet in here, and you have your layout on this side as well, so you can split your screen. Now if you want them tabbed again, but you right click on it and you say merge all. Now they are tabbed again, or you can do that from the window menu as well. Here you can do that horizontally, vertically, and you can close all of them or close the current document, this one. Or what you can do, you can make the window float. What I mean by that, if you resize this, let's say like that, if you drag, left click on the mouse, drag and move outside the window, now you can start another editor. Now one for schematic, one for layout. This is particularly useful when using Altium Designer across multiple monitors. Usually I have 3 monitors on my desktop in the office. Usually I put one for schematic editor on one screen or one monitor. I put the layout on another monitor, and the third monitor I can use it for components or manufacturer parts, as we will see, or messages for DRC and ERC. So this is very useful if you have multiple screens or multiple monitors. So basically, if you want this back, you can just drag and drop it again, and you can close this one, close only this window, and you can expand back the main editor. Now there are some user editable preferences that control how the document bar works. In order to access that, you can go to the settings. In the settings you have the system, under the system you have the view, and here we have the documents bar. So this group document if needed. By document kind, what does this mean? If the bar here is full, all the schematic sheet will be grouped into one, and then you will have an arrow here. When you click on the arrow, you will have a drop menu to select which schematic sheet to access. This is by document kind. By project, if you have multiple project in the project menu in here, so all the documents, regardless if they are schematic or layout, they will be grouped into one group, and then you can access them also by the arrow, small arrow in here, and we will see that later on. Now control tab switch to the last active document. Now instead of cycling them one after another, then this will go to the last active document, and this is actually useful if you have multiple schematic sheet open and you have the last one to be the layout, and you are switching between the layout and other schematic sheets, so you always can go back to the layout. Now if you click on the center a click will close the document tab, active document tab. Basically, if I click on this with the center button on the mouse, it will close. So these are some nice nice preferences to take a look at, and there are a lot of preferences for Altium, and we will go over 90% of them, maybe the most useful ones, while we are going through this training or these sessions. It doesn't make sense for me to go over all of them in one session, because you will forget how to use them and it will take time. So we'll cycle through these and try to learn some of them when needed. Now let's close this. Now the second thing we need to talk about today, before we go to the panels, is these we have the menus in here, and here we can have access to the preferences and settings menu. Here we have panels on the left side. This is the editor. Based on the document type you have different type of editors. You have layout editor, you have schematic editor, you have bill of material editor, layer stack editor. We have so many editors. We will talk about them in our session today as well. Now the third element are the panels in here, in the down right side in here, bottom right side. You have different type of panels, and they can be classified into two groups. The first group of panels are specific to a particular document editor, and these are available only when a specific document type is in focus. Now we have the layout document type in focus now. You see these panels. Let's open the schematic document type. And let's take a look at these panels again. They are different. And the second type, there are some global system-wide level panels that are available regardless of the current focused document. So this is very handy, and this came in Altium Designer 18 and after. So before that, the panels are shared between different editors, and it was a little bit confusing to differentiate between the features. They can be used, for instance, in schematic or layout and so on. So Altium 18, version 18 and after is more user friendly. So when Altium Designer is first started, a number of panels will already be open, such as the project panel. It will be on the left side, or for instance, the component panel will be on the right side, and this will be docked, as you can see in here. Of course, you can change that. Now, once you open specific panels or close specific panels, even if you close Altium Designer and open it again, it will restore the last configuration you made to these panels. So if you want to open more panels or explore more panels, use the panels button at the lower right in here of the workspace to access any of these panels. And again, the availability of the panels in here depends on the editor in focus. So I encourage you to try to explore all these panels. We will go over all of them, of course, during this course, but I encourage you to spend some time on that and try to open one by one and see what kind of features and options available on each of them. Now, one comment I would make in here, if the panel button is not shown in here, make sure that the status bar is active, is checked in here. So if this one is not active, you won't see the panel button at all in here, because the panel button is part of the status bar. So you can click on status bar in here, and you will see the status bar at the button in here. We'll talk about the status bar, of course, and you will see the panels button in here. Also, you can access the panels from a view panels, and you will see it. And this is also a dynamic menu. So when you switch to schematic, if you go back to view panels, you have a different sort of panels in here depending on the active document type. So these panels have three different display modes. The first one is called docked mode, where the panels are permanently displayed within the workspace. And the second one is called pop-out mode, where the panels are hidden, appearing when their buttons are hovered over or clicked on. This is basically called, when you see this, it's docked mode. So if you move away, it will hide. If you move close, it will pop up. So the third one is called floating mode. The panels will float over the workspace, becoming transparent whenever the cursor approaches. So let's take a look at each one of these. Let's start with docked panel mode. These can be docked horizontally or vertically within the main application window. So if we click on a project in here, let's close the schematic. So let's make it in docked mode using this pin. So this panel will be always there. You can access it anytime. You can see the content all the time. Now, if you right click on it, allow dock, you can dock it horizontally or vertically. Now it's vertical, and the only way to dock this is vertical. So if you activate horizontal docking, basically if you drag, let's go to here for instance, drop, and it's docked now horizontally. If you click on it again and drag it and move to the left side, leave it, and now it's docked vertically. You can also dock it to the right side or left side, top and bottom, based on the settings you select in here. Now the second docking mode is the pop-out mode. So in the pop-out mode, the panel will appear as a tab on the application border. So either on the left side, right side, or bottom or top, any one of the borders depends on where you dock the panels. So here we have 1, 2, 3, 4, 5. By moving the cursor over the panel tab will result in the panel sliding out from the border, as we can see in here. Moving the cursor away from the panel will cause it to slide back again. Now, if you don't want to wait until it slides out by hovering, basically just click on the border of the panel and it will open immediately without animation. And for the animation mode, the speed at which the panel slide out and in can be controlled in the system preferences as well. If you go to the preferences, under the view, here we have pop-up panels. You can control the pop-up delay and the hide delay. So you can make it, let's say, small delay. It will pop up very fast, and you can use the animation in here. This is the animation speed, so it's a slide smoothly, fast or slow. So let's see now, it's much faster, a little bit faster comparing to before. So if I move back or away, it will hide. Now the third mode is a floating mode. Basically, let's take for instance this component. You can left click, drag and drop. And this is also very handy when if you have another screen. Usually I put this component menu on a different screen, or let's take for instance manufacturer parts here. Also I have this usually on separate screen. It's very handy because, and you use it all the time. And let's open it like that. So let's say we selected this component, right click on it. If I want to say place, it's loading. Now you see how the panel became transparent, especially when you move the component over the panel location. If you move it away, the transparency will change dynamically depending on how far you are from the panel itself. Let's cancel it. Let's dock it back into here. And this is called the floating mode. So if you have the panel over the components and you don't want this panel to interfere with the editor, this is good mode. Now you can control the transparency of this panel also from the preferences. So you go to there is transparency in here, and this is transparent floating windows. If you disable this, it will not be transparent at all. It will stay as it is. So activating transparent dynamic transparency, meaning depending the software will look how far you are moving the cursor from the panel borders and change the transparency based on that, as we have just seen. Let's close this one though. This is good. We are learning these preferences by example. So we took a look now at this transparency. We also took a look at a couple preferences in the view window. Now this is a nice thing. So the user interface theme, this is the Altium dark gray theme, which is the one I'm using in here. It's very nice. The old theme, if any of you use Altium 17 or before Altium 18, they had the light gray mode or the white mode. So I prefer this one. I will stay with this one. If you prefer the light one, you can go and select the light one from here. Now for the panels, they can be grouped in two different ways. The first one is called tabbed grouping, where only one panel in the group is visible at a time. So like in here, we have different panels in here, or let's take a look when the panels are docked. We can open, for instance, schematic filter. And let's move these away and schematic filter as well. Okay, put it on the side. Okay, so like in here, put it back. So in here, so only one panel is available at a time, as we can see in here. So basically, to have this mode, which is a tabbed panel grouping, let's say we have another panel schematic list. So just drag the source panel over the center of the target panel. You see these arrows on the top, bottom, right, left, and all four corners. Now, the entire area of the target panel will become shaded blue to indicate that the panel will become a single tabbed group. Releasing the left mouse button will group the panels together, and you can cycle between the panels from the tabs in here. So this is called tabbed panel groupings. So the second one is called fractal panel grouping, which allows multiple panels to be grouped and visible at the same time. Now to group the panels in this fashion, just drag the source panel towards the small arrow icon. So let's take for this one, for instance. If you drag it to the small icon on the top or on the button here, let's say, and here we can resize. Now you can see the properties panel and the schematic list panel in the same time. But the properties panel and schematic filter, they are still in the tabbed panel grouping. So if you want to see all the three of them in the fractal panel grouping, also you need to drag the schematic filter to the top arrow, or you go to the bottom arrow depending on the location you want this panel, and now you can see all the three panels in the same time. Usually I don't use this because you need now to resize the panel and it's hard to see unless you have a very big screen. So what I prefer to use all the time is the tabbed panel grouping. To go to the tabbed panel grouping, basically left click on the mouse, hold it from here, and make sure it's in the center, as you can see in here. It's not to the arrows. Here we go. Oh, it's appeared. It's okay. So you can go back to schematic filter, move it back to the center. If you go to one of the arrow, it will go into the fractal. If you go to the center, it will go to the tabbed, which what we need. This is nice. This is what I use usually. Now one comment I would make in here, if you hold the control key while you are moving a panel, let's say this one, now this will prevent automatic docking or grouping or snapping as well. So there is no way I'm holding the key button down on the keyboard right now, so it will not dock. If I release the control, now it can be docked. So if I press on the control, so this will prevent any docking or snapping or grouping, so I cannot group it. And this is not only for the panels, also for the documents. So I release the control, now I can dock it again to the properties window. If I would change this one to the pop-up mode, I just click on the pen in here, move away, and it will hide. To close a panel or any of these panels, simply go to the X and click on the X and it will close. Also, you can maximize and minimize these panels. Let's say manufacturer part search, for instance. If you double click on it, but you need to have it in the float mode, if you double click on it, on the bar in here, it will be maximized. If you double click again on it, it will be minimized. You can drag it, drop it again, and it will be docked. Now the next thing we would talk about is the active bar, which is this one. If we go to the layout, there is a different active bar. If we go open different document, we'll see different active bar, which is very good thing. And this function also or this feature came in Altium Designer 18, and after that, before that, you had only active bar that share all the comments for different document types, which was a little bit confusing because you might select a comment that will not work in schematic or layout. So they made it more user-friendly in Altium Designers and the release after that, and now it's much better. You can see only the comment you can be used in the active document or the document in focus. So basically the active bar provides a point and click access to the commonly used commands and actions related to the document in focus. And this is called the contextual, meaning it will display commands according to which document has the focus, not other than that. By default, when starting a design document, the active bar will appear at the upper border of the focus document. And this active bar is customizable in Altium Designer, and we will see that later on. Now you can select a comment from the active bar by left click on the mouse. So move, just left click. To release the comment, just right click on the mouse, it will release it. So left click to select, for instance, move, right click on the mouse to release it. And if you hover the mouse over these comments on the active bar, you will see a tooltip describing the associated comment or the process you hovering over. And now some tool buttons will have a small down arrow inside their icon. Like here, you see these arrows, small arrows. That means there are more commands inside each one of these icons. This indicates that the tool button is a placeholder for several commands. To access the individual commands, right-click once on the tool button, and once the tool button expands, click on the lower level commands to select it. Like here, right-click. Or the other way, instead of right-click, if you left-click and hold down, it will also open the menu and you can select the command you want. So either by left-click and hold for around 50 milliseconds, or right-click on it and you will see the rest of the command under each one of these buttons, and they are related. So for instance, this is alignment command components or alignment command. So if you right-click on it, you will see all the alignment commands related to this icon. Same thing in here. Let's see for this one. It's routing. If you right-click on it, you have interactive routing, interactive differential pairs routing, interactive multi-routing, active route. So they are all related. Same thing in here. Let's see, for instance, this one. So this is for the dimensions. The default one is the last one you selected. If you select standard dimensions, you can use escape to release it, or right click as we said. So if we select this one, right click, it will release, or you can escape, it will also release. So you will see only the last command you selected. Let's select a different one, baseline dimension. So it's the default right now. So it will keep the last command you selected. Now if we go to the schematic, again we will see different active bar. If you right click, you will see the other commands under the same button. Here all the power ports, you can see them in here. Here you can see all the different type of wires. We have wire, bus entry, net labels. We are going to use all of these, and so no worries for now. Here we have different directives. This is the directive list, and here we have just text. Here we have regular shapes for drawing and so on. One of the new features came with Altium Designer 18, and after is the search bar in here that provides search capability in the workspace. So if you add any keyword in here, for instance wire, the search will return all the related comments and appearances in the system preferences and quick search. So simply click on any of these, it will start the command if it's a command, or if it's one of the preferences, it will open the preferences panel directly. So for instance, let's click on a graphical editing in the schematic preferences. If you click on it, it will come up right away. Or if you select wire and its command, let's say this is place wire, it will start the command right away as well. So this is very handy. Sometimes you need a command and you don't know where is it. So you go to the tools and you start design, and it's maybe place. So it's really, maybe it's faster to say port. So you have connector board, I can place the port right away in here if you don't know it. And this is very handy feature, and I like it and use it all the time. I don't always remember where is the location of these commands. Usually either I count on this or on more active bars that we'll discuss in a minute. We can show them in here, or the search is more handy as well. Or even if I want to search for preferences, I'm not sure if it exists or not. For instance, transparency, it's in here. So it's very hard to go over there and try to look for it. You either can search in here, so it's in here, or you can search for it in here also. This is direct access to it as well. This is very, very handy. I advise or recommend to use it. Now the menus in Altium Designers are very important as well, because Altium Designer makes extensive use of pop-up menus that are activated by right-click a specific region within the workspace. Similar to the panels, right-click menus are also contextual and display different items depending on what is underneath the cursor when it is active. In general, the purpose of right-click menus is to give designers speedy access to the most commonly used controls as needed. Altium Designer supports right-click pop-up menus in 6 locations, as I remember. So the first one is called in the document editor. So if you click anywhere in the document editor in free space right here, you will see a pop-up menu. This is right-click menu. If we go to the layout in the free space, we see also pop-up menu, and again they are contextual. Depending on the editor you have, you see different menu. And the second one is on object. If you right-click on an object in here, let's say we have here an object. If we right-click on it, also we see a menu. Let's go into a component, for instance. This is a component. If you right click on it, you will see different menu as well, depending on the object you are clicking on. If you go to the layout and select an object, right click on it, you will see also a different menu as well. So it's contextual, which is very good. So you only see the comments and the actions related to the object you are selecting or is being active. So the third type is when you click on the comment bar or active bar. If you click in here, you will see also right click menu, and on the bar in here, if you right click, you have some panels you can add schematic standards. So like open, save. These comments are mostly available in the file and edit. Also, if you right click formatting, for instance, this is a formatting will come in here when you click on the object associated with the some of the comment in this menu, you will see it. So the thickness of this wire, you can change it in here, and this is active. So if you click in the free space, it's no longer active, it's grayed out. So because it's also contextual, you can change the color, for instance. If you click in the free space, you cannot change the color from here. So again, utilities. So let's bring the utilities in here. So some of these comments are available in here, some of them not. So right click, let's see, wiring. Let's bring the wiring all the way in here. Usually I keep these available. So the wiring, you see some of the comment in here, they are in here. So VCC and ground, they are in here, but these are like 90% of the time are used. So instead of going in here, right click and try to find the VCC and GND among all these different port, it's in here right away. You can have direct access to it or quick access to it. So these are the wiring. Actually, all of them are available underneath in this comment in here. So, but here you have direct access to all of these. So you don't have to right click, select, and take the comment. Here, just one left click in the mouse and you have the comment. So navigation is basically here will show you the location of this project. And also this is, and usually I keep these active all the time, and they are useful for me. Again, if you go now to the layout, there are different set of comments in here to add as well. So PCB standard, in the schematic, we have schematic standard. Now we have a PCB standard, we have filters. So we can arrange this one in here. And usually I keep the filter on the right side. So basically you can select the component you want to filter. You can filter a net, or you can filter a component. If you select a component, it will go right away to the component. This is nice. Also, there is a filter panel for that. So let's release it. We have utility, similar things. This is for alignment and stuff like that. Change the grid. We'll talk about all of that. Wiring. And the wiring in schematic is different comparing to the wiring in the layout. In schematic, you have nets. In the layout, you have traces. So don't mix. Navigation, same thing. I also keep these active all the time. So again, in the document editor, we talked about that. You can arrange the document or close and open any of them. Try to explore the right-click menu in the status bar, on the objects, on the free space, and schematic and layout. You need to practice to master the tool. Now the shortcuts, sometimes if you don't know a shortcut, you can click, for instance, on the comments and you will see the shortcuts next to the comment title in here. Or if you right click, also right click menu, you will see the shortcut for these comments. If you select an object, for instance, schematic, also you can see the different shortcut. Also the shortcuts are customizable. We'll see that later, how we can customize the shortcuts. Here for actions item, these are the shortcuts. Even in here in the menu in here, let me see if they show up. there is no shortcuts in the menu. So just the right-click menus, you can see them. And also the menus in here, you can see some of the shortcuts that by default available in Altium Designer. And let's search for shortcuts. You can search for shortcuts. So help shortcuts key. If you click on it, it will bring you to Altium Designer 19. And so if you select anything and click F1, so all that you need is to have F1. So let's close this. So basically, if you are on the free space and no command is selected, if you click on F1, so the help menu will pop up. Now, if you have, it will take you, of course, to the document on the website. Let's say if you selected window, for instance, in here, or design, if you click F1, let me bring it from the second screen. So it will show you the associated comment you are hovering over. Now, if you select a comment, for instance, let's select wire, place wire, and now click on F1, the hotkey list will come up. Now, these are all the shortcut keys associated with the command you are selecting, which is very nice. So here, for instance, if you click on space, this will toggle the wire start end mode, shift space, cycle wire placement mode, tab change through dialog box, and so on. If we click in here, I'm clicking on the space. Now if I click shift space, change the direction of the wire and so on. This is how you can access the shortcuts. So I will provide a list of the most commonly used shortcuts in schematic, layout, and libraries as well. So if you want to add to these, you can add to these, but I found these handy and use them all the time. I will put the list and publish it with this video as well. Now we have the status bar at the bottom of the window, and also the information displayed on the status bar contextual, meaning if you switch to the PCB, the information will be different depending on the object you select or if it's in the free space or not. So on the left side, you will see the position of the cursor and information about the grid in here. So if you move the cursor, you'll see the new placement of the cursor. Now, if you click on a component, for instance, or you select a comment, let's take wire, for instance, here. So now you will get some information, shift plus space in here to change the mode. So if you click shift and space, and it will show you also the mode. And yes, if you click and start routing, you will see now on here the coordinations of the cursor with the wiring active. If you click shift space, you are changing the mode again, and you can see get information. That's why this status bar is used for providing information about the command you are using. Sometimes you see shortcuts as well in here and the coordination. If you go to the layout, now let's move away to the free space. The free space is the place where there is no components or traces, vias, or anything has to do with the PCB layout. So if you move in here, what you can see is also the coordination of your mouse relatively to the reference point. The reference point is basically this. If we come closer, this is the reference point, and usually it's set at the bottom left side of the board. Of course, you can change this one from edit. You can go to the origin and set. Once set, let's select this corner. Now this is your origin point. If you put the cursor at this point, now you see the coordinations are 0, 0 on the status bar in here. Look, let's take a look. It's 0, 0. Now if we move away from this point, you see this is negative because we are moving to the left side or the bottom side. This is negative in the X, this is negative in the Y. Now if you move to the right and top, become positive. And also the grade, it's saying the grade now is 1 mil. We'll talk about the grade, of course. Now if I change the grade to 10 mil, now you get information about the grade. And also it said the hot spot snap is enabled. Now if we select a comment, for instance, let's select wiring and let's click on this bin, and now I have wiring active. We can see now the track is using the hug and push obstacles mode, and it's 45°. Now if I click on shift and space, I can change the mode. Now it's 90°, it's a free mode, 45°, and we can see information about the net links on the bottom side. Let me freeze it in here. Freeze it will hide. So we can see the net links. It provides information about how long this net you are routing is, and this is very also handy when you have links matching, manual links matching, because there is automatic links matching we'll talk about. And also you will see if there is a via, and is it through hole. If you are gonna use a via or add a via, is it gonna be through hole or different type of via, and the number of layers. If it's through hole, it will go from 1 to 4, and the via size will follow the rules preferred, and you will get full information about the wire you are using as well. So there is net links for into. Into is the name of the link. Sorry, if it's the name of the trace. So this is the status bar. Basically, it has also information about the status. Now let's release this command by just click on escape. And don't forget that the status bar also includes the panel display button in here, schematic or in the layout as well. You can see it in here. Now after you configured the comments, you have the bars, the panels you want to be open, the sizing. Basically, you can save the environment layouts into a file. So if you move to a different machine, you can just transfer this file and load it into Altium, and Altium environment will be configured according to this configuration you have. And basically, to do that, you go to the preferences again, and here you have a desktop. And here, restore open documents. Basically, if you close Altium and you have this project open and these documents are open, next time when you start Altium, Altium will automatically load this project and these tabs as well for you. Now, if you save now this environment file, it's saved layout. Basically, if you remove Altium and install Altium again, and you have this file, you go to load. Let's save it first. You go to load and click on load, and Altium will automatically restore. Now Altium restored, as you can see, if you have all these closed, Altium will open them again. So you have a configuration of the Altium environment set based on your convenience, and you don't have to do it every time. For instance, if you put shortcuts, if you have some comments in here on the status bar, or something, you have specific panels configured in here, the docking mode, etc. You don't have to do that every time you switch from machine to machine, or you uninstall Altium and install it again. So you can save your configuration and use it all the time, and this is also a handy feature. Now, in addition to saving the desktop layout, which save the position of these panels and toolbars, etc., you can also save the preferences. So we have changed several preferences in this panel. So after you change so many of these, also it's very helpful for you to save these preferences. Also, if you switch to a different machine and you need to install Altium again, you can save these and you can import them in one click, and the environment is ready for you to use. And to do that is basically you go to save in here and you call this my preferences, for instance, my preferences. I can mark it, for instance, let's say Walid 2019, and I can save it. Now, it will save all the changes applied to all these different preferences, and they are a lot. Trust me, if you have um, specific preferences and you need to change over all of them, it will take you time to remember, oh, what can I change? So it's one click you can save them. Now, when you want to load them, you just click on load, and now you will get the option to select which preferences to import. Now, if I click on it, show options, and now you can tell Altium, okay, these are the list. Only import preferences, for instance, I don't want for material library, I need the rest, or you can remove stack manager preferences, and I might say, okay, I only need the system preferences and I'm not interested in anything else. Even in the system, you can also select which preferences from the system to import. If I need only this, now you click on OK and you can import these preferences to your computer. And instead of doing that, going onto these preferences one and one and try to set them according to your requirements. Now that's enough about the preferences and the environment, but let's take a minute to talk a bit about design documents in Altium Designer. And if we switch back to the slides, we talked about Altium environment, now Altium design document types. Before we go to the types, let's see how we can create a document very quick. We are not gonna go through how we create a project because the next session, the whole focus will making our first PCB from A to Z. We will create a small project. We will have a schematic, we'll have a layout, and we will get all that done in one session. So it will be quick overview about creating a project in Altium Designer. But now we're still trying to take a look at the environment, understand different document types, project file formats, and so on. So to start a document, basically you can go to File, New, and you can select either schematic document, PCB document, active bill of material document, draftsman, which is mechanical drawing. We'll create all of these, so don't worry about it right now. CAM document, output job file, components. You can do libraries, scripts, mixed signal simulation, project group. All these are different documents in here. So if you want to create project, also the project is a kind of document. You can open existing document in open, close, you can close the document in focus right now, or you can open a project or project group and you can save as well. Now when you click on new and select a document, this will go automatically to the project that is in focus right now. It will be added as one of the project documents. For now, we have this project that is active in here. So if I click on, let's say, new schematic, this schematic goes underneath this project and it will become part of this project. If I drag and drop this outside this project now, it's free document. It's not related to this project anymore. If I need it to be one of these project schematic sheets, basically I can drag and drop it inside this project. Now, if I want to delete it, it's not part of my project. Basically, I can click on remove. It will become free document. I can remove it now from the workspace completely. Close. It will be closed. Now, if I need to, in addition to here, I can go right away to here and right click on this project. I can add new to this project specifically. Now, for instance, if you have multiple projects and you need to add a document, specific document to a specific project, you can go right away. Let's add active bill of material, for instance, document to this project. This might take a time because it will start to read all the available components. Let's wait for it. It will come up very soon. Here we go. Okay, now we have a new document. have the same project name, but it has a different format. It's POM doc. So now it's important to understand what type of documents we have, because now we have this star indicate that these files are not saved, and this file is not saved as well. So what we can do, if we click now on save, now everything is saved. Now this format automatically is generated by Altium depending on the document type you selected. Let's go back to the slides to see different document types. Now we can group them. They are grouped in Altium and classified. I'm selecting now just the important document types to go over them. So you have project files. For project files, so the PCB project file, which is the main project file, is called BRG PCB. And now this is an ASCII file, and the editor is a project panel. If we go back to Altium Designer, this is a project panel, and this is the BRG PCB. This is the main, this is the parent for the whole project in here. It has a format BRG PCB. If you go to the directory where this project is saved, you will see this file as well. So BRG FPG, this is for FPGA project file. You can do FPGA in Altium, by the way. Core project file, this also has to do with embedded applications, project embedded project file, script project, library packaging project, and here we have tasking project file. These are all ASCII files. You can have an access to these and edit them, remove them, control them in the project panel. Now the second set of document types are under project collection files, project group, and design space work. If we go in here, this is the design space work. As we can see, this project under this design space work, and there is also project groups where you combine multiple projects. We will have also a session to discuss these two. Now the third type are the common PCB design files. They are classified under the design files. So you have the .schematic and .schematic DOC document. So here we have schematic doc. As we can see, these are all schematic documents, and these are schematic capture files. PCB doc, this is PCB layout file. If we come here, so PCB documents, PCB layout file, and all these are binary files in here. So if you go schematic library, this is for schematic library. When we learn how to create a component symbol, we need to create schematic library for that, or schematic library. PCB library also for footprints, integrated library that integrate the schematic symbol and the footprints and link them together. It's called integrated library because it integrates components inside one library. So we have netlist files. These are ASCII files or text files. And we have other type of files. We'll go over them in the right time. So here we have the MISC files. Also we have, these are text. Basically all of these are report, log, bill of material, electrical rule check, design rule check. Also we have the fabrication files, goes under the CAM, drill, pick and place, and the G files. These are also, they can be edited by the text editor, any text editor or CAM editor. 3D model files, you can import any of these formats into Altium Designer when either you create a symbol, component, or you want to import enclosure, for instance, to do clearance check or clearance analysis. You can have any one of these formats. These are very common formats, STEP or the Parasolid or SolidWorks file as well. So if you need to have more information about these files, basically you can go to the directory inside the system folder where Altium Designer is installed, and you can try to find these two files. Let's do it right now. Here is the file. Let's take a look. See directory. It's in program files. Let's see, program files, Altium Altium Designer 19, it's the system, and we need to search for file filters and file extensions. File, here, file extensions and file filter. If right click on it, open it with any text editor. Let me open it with Notepad++, and here we go. So here you can see all the different file extensions supported in Altium Designer. So x_t, x_b, these are Parasolid and step files. We can see these are for the 3D model document exist in here. And you can see all different kind. So PCB model data, simulation data, IBS, also these are simulation, etc. So if you take a look at the file filters as well, you can see these are all the formats supported by Altium Designer. There are a lot. So if you need more information about that, you can come in here. For instance, schematic files has all these formats: schematic doc, .schematic, OpenBus, FSM doc, and you can have more information about this if you go to the help. So schematic libraries, for instance, this is for symbol library. Schematic library, you have schematic library or dot library and so on. Okay, here again, if you want to see what file formats are available in Altium Designer, you can see them in here. Okay. Before we go to the project type, let's talk about document insight. Let's go back to Altium. So basically, document inside, when you hover over a document icon, there will be like a small window shows an insight about the content of this sheet if active. Now, if I hover over the document icon in here, it's not showing anything because it's not active. And to activate that, you need to go to the system, and there is a design insight checkbox. If you click on it, it will be active. Let's do it. Click on the preferences menu. Under the system, there is a design insight and enable document insight, and there is enable project insight. Basically, when you hover over the project icon, you will see an insight for all the sheets, all for the children underneath this project. Let's enable both of them and take a look. Now, one thing you need to note in here, in order to have an insight to a document, this document has to be open. So let's see if we hover over, let's see this one, you will see like small preview of the content of this sheet. If we go, for instance, for the GBS, and this will say open GBS schematic document to generate a preview. You need to open it just one to generate a preview, and this preview will be saved in the same project folder. If you go to the project folder, desktop, it's in here. This is OU. There is a preview folder in here. If you click on it, these are the previews saved inside this folder. So Altium will try to find this preview inside this folder. If not, you need to open the document to generate this preview. So same case for storage, for instance. If you hover over it, it's not there. You can open it. Let's open wireless. Let's open all of them to generate the preview. So now if you hover over the project, now you will see all the sheets or all the children's underneath it. If you click on the picture, you will switch right away to the corresponding document. So if we click on this one, we'll go to this document right away. Now let's try to minimize this window, and now you see all these documents belong to the schematic documents are grouped inside one tab. And this is the grouping we are talking about. So you have two options for the grouping, either by file type or by the project. So if we have multiple projects, all the documents related to one project will be grouped under one tab, and you can access now the sheet you want from this menu in here. So let's maximize it again, and they are no longer grouped in here. So I think that's enough for the environment, and let's see the project file formats in here. So basically we have four essential project types, which are the project PCB project. It has a format BRG PCB. We have seen that. If we go back to the environment, this is the BRG PCB, which is the project for a PCB that include all the files related to the same project: schematic, layout, fabrication file, assembly file, libraries, bill of material, etc. All files associated with one project are within one container called project PCB. So project PCB is like can be considered as a container that package all the files related to one project. Now, multi-board project, there is an example in Altium Designer for multi-board project. So if you open a project and go to the local project, Altium Designer examples, there is mini PCB, and this is BRG MBD, multi-board project or multi-board project. If you open it, that's this one. So inside this one, you can see how many projects you have. You have 3 projects combined within one called multi-board project. The reason for that, if you are designing a motherboard and you need to fit on this motherboard, let's say RAMs, you have a graphic card and so on, and you need to see how they all fit together, especially when you design an enclosure and you are doing clearance analysis, and in this case you need to use multi-board project. So if we open, for instance, the layout in here, will be loaded. In here we can see the progress bar. In here show you loading multi-board project assembly. So until it opens, we can go to the slides and come back in here. So this is multi-board project. So you can create, let's say RAM, create wireless module, create a motherboard, which the baseboard, create a controller, and then these are separate projects. After you finish each one of these, you can import them into something called multi-board project. And this multi-board project will do an assembly for these from a high level. It's not design level, but it's from a high level perspective. It's okay, it's loaded. Here we go. You can see the 3D model. Basically, as we said, this is okay. It's, as you can see, it's 4 projects. The first one is the PCB. The second one, you see it's here it's highlighted in here. It's a RAM. The third one, it's also a RAM. This is DDR4 RAM. The last one is Wi-Fi communication module, and all of them are assembled into one. And then you have this enclosure, which is the base on the bottom. As you can see now, we can select any of these and try to see how they fit together. So if we open this, you can see the design file for this project, and they are all combined into this multi-board project. Also, we will have a project to work on and see how we can combine multiple projects into one and do the assembly. So for now, this is just a quick overview about it. Integrated library package. Also, when we create a library, and we'll have something called library package that packages the schematic symbol library and the footprint libraries as well into one library package, where you link the schematic symbol into the associated footprint or multiple footprints. So script project, also Altium Designer support script, which is a set of instructions that are interpreted whenever a script is executed in Altium Designer. The scripts are written and debugged in the same environment, so you don't need to go outside Altium to do a script. You can write the script within Altium Designer, and there are 2 types of scripts: script units and script form. A script unit can use the application programming interface, which API, to modify design object on the design document. Script form hosts control as well as using the API to provide script dialog that act on design document upon open in Altium Designer. If any of you used Eagle Catsoft before, Eagle support also similar things called ULB, user programming language. It's a kind of XML type programming language for scripting. The other type of project files, I don't have subscription for these, but you can do FPGA programming in Altium Designer and also programming for embedded devices and core devices. You need to have like special plugin and subscription for these to be active. And I don't have experience with these, but I brought them in just to be aware of that. I think that's ends our session today. In the next session, we will start with a project. We'll start with creating simple project. And what I have in mind is to create the first project using through-hole components. So all the components on the board will be through-hole. And it's going to be simple, 2 transistors, couple resistors and capacitors and connectors as well. So it's we are gonna design an oscillator, and just to see what is the difference between through-hole component and surface mount component, because next your homework will be to create the same project using surface mount component instead of through-hole components, and this will be also nice to compare the size required to create the same simple circuit with through-hole component versus surface mount component, and we will do a comparison for the size. Now after that, all the project we are going to do and work out through this training or class will be based on surface mount component, unless we need to use through-hole component like connector or something. So that's all for today, and thank you all, and see you in the next session.